morning, my friends. It's Wednesday, December 20th. Oh, I'm so tired. Thank God I'm on winter break here for a couple of weeks. Christmas is right around the corner. Just going to be eating so much food. It's, what is it, episode 20. It's December 20th today. So let's find the 20th compartment of chocolate on the Lindt Advent Calendar. I really hope you've watched all the other episodes of the AP Calculus Free Response Question Advent Calendar. As always, there's a link in the description. You can check that out if you're interested. Or, of course, you can watch my hundreds of other calculus videos. Check out my Calculus 1 exercises playlist. If you're taking calculus right now, you gotta check out that playlist. Oh my gosh. There it is, compartment number 20. So I'm going to crack into this, and I will put today's free response question that we will be completing on screen now. You can give it a read, give it a try. It's a problem that kind of feels like it's really trying to be complicated and difficult. I don't think it's really going to be that bad, though. It's cute, you know. It gives us this algebraic definition of a function. It gives us a graphical function, and I think we also have a table, a tabular function. They're all three different functions. It's pretty cute. I can't say I've seen a lot of free response questions quite like this one. So it should be fun. Almost as fun as eating all of these chocolates. Just kidding. It's way more fun than eating chocolate. Really running out of boxes on this thing. I feel like I bought this a lifetime ago. Oh man, that's what doing, free response questions every single day will do to you. All right, let's do it. Let's do the calculus. This is free response question 6 from the 2017 AP Calc AB Exam. This is part of the no calculator section, and there's quite a bit going on here. It says, let f be the function defined by f of x equals cosine of 2x plus e to the sine x. Let g be a differentiable function, and we have a table right here giving values of g and its derivative g prime at a few values of x. Finally, let h be the function whose graph, consisting of 5 line segments, is shown in this figure here. So we have one function given algebraically, one function in a table, and one function in a graph. Part A. Find the slope of the line tangent to the graph of f at x equals pi. To find the slope of a tangent line, we just need to take the derivative, so we'll find f prime, and then we'll plug in x equals pi. So here for part A, the slope m of the tangent line is f prime, the derivative of our function, evaluated at pi, right? We're looking for the slope of the tangent line at x equals pi. So let's take the derivative of f and plug in pi. The derivative of cosine 2x is negative sine of 2x, but by the chain rule, we also have to multiply by the derivative of the inside function. The derivative of 2x is 2, so we multiply by 2 out front. So negative 2 sine of 2x, that's the derivative of cosine of 2x. We also have to add the derivative of e to the sine x. The derivative of e to the power of a function is just e to the power of that function multiplied by that function's derivative. The derivative of sine x is cosine x. So this is our derivative, f prime, but we want to evaluate it at pi. So let's go ahead and replace these x's with pi's, which of course is going to work very nicely with these trig functions. All right, after plugging in pi's, what do we get? Well, sine of 2 pi is 0, so this whole term goes away. Sine of pi up here is also 0, so this is e to the power of 0, which is 1. So all that's left is cosine pi, and surely you can remember your unit circle. Cosine pi is over there, where the x-coordinate is negative 1. So that's just going to be then negative 1. That is the slope of the tangent line at x equals pi, the tangent to this function f. All right, part B. Let k be the function defined by k of x equals h of f of x. F of x is the function we were just working with. H, remember, is the function shown in this graph. The question is to find k prime of pi. So let's go ahead and write part B here. We are looking for k prime of pi. So let's just find k prime of x, and then we'll plug pi in for x. K is a composite function. it's h of f of x. So to find the derivative, k prime, we need to use the chain rule. The chain rule begins with the derivative of the outside function. The outside function is h, so that's h prime of, leave the inside function unchanged. Then you just have to multiply by the derivative of the inside function. In this case, that's f prime of x. Alright, but we of course want to evaluate this derivative at pi. So k prime of pi is going to be h prime of f of pi multiplied by f prime of pi. But we just evaluated f prime of pi in part A. We know that's -1. So let's just replace f prime of pi with -1. All right, now let's see, what is f of pi? Well, looking up at our function, what f of x actually is, we can see that f of pi would be cosine of 2 pi plus e to the sine pi. Now, cosine of 2 pi is the same as cosine of 0, which is 1, and e to the sine pi is e to the 0, which is also 1. So this is 1 plus 1, or 2. So we can rewrite this as h prime of f of pi is 2, so this is h prime of 2, multiplied by -1, so we'll still put that -1 there. Now, what is h prime of 2? Well, we'll have to look at our graph to figure that out. Since we want to know the derivative of h at 2, we're looking right here. So here's x equals 2, and we're focusing on this line segment. The derivative of h is the slope of h, which is easy to figure out when h just behaves like a line. What is the slope of this line? Well, we see that when it goes down 1, it goes over 1, 2, 3. Rise over run, so the slope is -1/3. Down 1 over 3. Okay, so h prime of 2, the slope of the function h at x equals 2, is just the slope of this line, which is -1/3. So this is -1, which I'll move to the front, -1 times -1/3, which of course is just +1/3. All right, let's move on to part C. Let m be the function defined by m of x equals g of -2x times h of x. We want to find m prime of 2. So this is a lot like the previous questions, except now we're getting the g function involved, which is in this table, and we're going to have to use the product rule because, of course, we're now dealing with a product of functions. We're dealing with g times h. So let's put problem C down here, and we're trying to evaluate m prime of 2. Let's begin by just finding what m prime of x is, and then we'll plug in x equals 2. We, of course, need to use the product rule, u prime v plus v prime u. So looking at this product, let's start off with the derivative of g. The derivative of g with that -2x inside of it is going to be g prime of -2x, and then multiply by the derivative of the inside function. The derivative of -2x is -2. So that would be the u prime in the product rule. U prime v, so we also have to multiply by the second function here, h of x. U prime v plus v prime u. V prime is the derivative of the second function, so h prime of x, times the first function unchanged, g of -2x. All right, that's m prime of x, and now we just need to plug in x equals 2. What is m prime of 2? Well, it's going to be -2 multiplied by g prime of -4, because that's -2 times 2, multiplied by h of 2, plus h prime of 2, but h prime of 2 we already figured out was -1/3. That showed up in the previous problem. H prime of 2 is -1/3. So let's just replace that with -1/3. Get a little head start there. And then we have g of -4. All right, hopefully we can figure out what all of these values are. Let's consult the table for the values of g and g prime. G prime of -4 we see is -1. And g of -4 is +5. So we can rewrite this expression. It's going to be -2 times g prime of -4, which we know is -1. So -2 times -1, multiplied by h of 2 plus negative 1/3 times g of negative 4, which we see is positive 5. So this is times positive 5. Now we can simplify and also figure out what h of 2 is. For starters, we have negative 2 times negative 1, which is just positive 2. And then looking at the graph, what is h of 2? X equals 2 is right there, and so h of 2 is the y value right there. Now, how do we know what the y value here is? Well, we know that this line segment starts at the origin, 0, 0, and we already said that its slope is negative 1/3. So if we move over 2 units, we must go down 2/3. So the y-coordinate is negative 2/3. That is h of 2. So we'll replace that right there. We're replacing that with negative 2/3. And then over here on the right, we have negative 1/3 times 5. So that's minus 5/3. Finally, this is negative 4/3 minus 5/3. So that's negative 9/3, which is just negative 3. That completes part C. So let's finish with part D. Is there a number C in the closed interval from negative 5 to negative 3 such that g prime of c is equal to negative 4, and justify our answer? For this, part D, we must use the mean value theorem. We know that g is differentiable, and thus it's also continuous on the closed interval between negative 5 and negative 3. We are told as much. G is a differentiable function, and we have some values of g and its derivative. That's what's going to let us use the mean value theorem. Since g is differentiable and continuous from negative 5 to negative 3, the mean value theorem tells us whatever g's average rate of change over this interval is, there must be some point in the interval where its instantaneous rate of change, its derivative, equals the average rate of change. So let's calculate g's average rate of change from x equals negative 5 to x equals negative 3. To do this, we'll set up a fraction. The calculation is as follows: g of negative 3, the ending value, minus the starting value, g of negative 5. This tells us how much g changed over the interval. And then we have to divide by the interval width, which is just the endpoint, negative 3, minus the beginning point, negative 5. All right, so this is how much the function changed divided by the interval width. G of negative 3, we see from the table, is positive 2, and g of negative 5 is positive 10. So this is 2 minus 10, and then the denominator, negative 3 minus negative 5, is negative 3 plus 5, which is just 2. We see then that this is 2 minus 10, which is negative 8, divided by positive 2, so this is negative 4. Since the average rate of change over the interval is negative 4, we know by the mean value theorem that yes, there does have to be some point c in this interval such that the derivative of g at this point c is negative 4. The instantaneous rate of change has to equal the average rate of change at some point on this interval. And there is that conclusion written out. And that completes our solution to free response question 6 from the 2017 AP Calc AB exam. Let me know in the comments if you have any questions. Be sure to check out the full AP Calculus free response question Advent Calendar playlist. There's a link in the description. And if you find these videos helpful, please consider supporting Wrath of Math by joining as a channel member for access to additional content, including exclusive calculus videos. Thanks for watching, and I'll see you tomorrow for the next episode.